Welcome back, everybody. This is our video for section 6.5. It's going to be shorter than most. That's good. A lot of the procedures we do have to do with working with a normal distribution, and so it's a good idea to know if you've collected some experimental data or survey data. It's a good idea to be able to determine if the data is from a normally distributed population, or at least is likely to be from a normally distributed population. So we have a couple of tools that can help us with that. One would be just to make a histogram of the data, just plot the data, make a histogram or bar chart of the data and see if it looks roughly bell-shaped. Another tool that we have is called a normal quantile plot. It's also called a normal probability plot. It's also called a QQ plot, depending on what book or software you're using. So what it does is each X value, it's an XY plot. Each X value is from the original set of sample data, and each Y value is the corresponding Z score. So if you were to plot along the horizontal axis, your X values would be your raw data, and the Y values would be the Z scores. You'd get a normal plot. Okay, so here's an example of one. Shown to the left is just a set of data that's not really bell curve at all. And to the right is a normal QQ plot for it. And across the horizontal axis, actually, the software I used to generate this one, the sample data on the vertical axis and the Z-scores on the horizontal axis, but that's okay. We have this kind of curve shape, which is the actual QQ plot, and along with it, the software has plotted a line of best fit. Here's another example. This set of data should look more normally distributed than the first set of data, and you can tell by looking at the QQ plots. On the set of data where it's more normal, that line of best fit, the data more hugs that line of best fit in comparison to the data that wasn't normal. You can tell on this one where the QQ plot is, the data values deviate from that line of best fit at both ends. Although it hugs the data in the middle, but at the ends it deviates quite dramatically, and so that would indicate that the data set is not really normally distributed. On a set of data that's more normal, you'll have the data values more closely hugging that line of best fit. Its slope and everything doesn't matter. What matters is how well does the data really kind of hug that line. There are a couple of values that deviate from that line, but they are way at the ends. The bulk of the line is the bulk of the data lies on that line. Here's another example of a QQ plot. This one is mostly bell curved, although this one does have a right skew to it. What would tell you that this one is right skewed is the fact that the data curves away from that line of best fit in the upward direction. If the data curves upward from its line of best fit, that would indicate a right skew. If you have a set of data that is left skewed, notice the longer left tail on this histogram, the data curves downward away from that line of best fit. This data set is bimodal, so there's two bumps basically, and so it's pretty clear that the data really deviate from that line of best fit. So in the QQ plot. So having the QQ plot or normal probability plot is just another view of the data that you can use along with the histogram to get an idea of how normal a set of data is or not. It just gives you another view of the data. So if you're getting ready to do some sort of statistical procedure and you want to know, okay, is my data from a normal population or not, here's kind of a procedure to follow. Step one would be to make a histogram. You want to start with a picture of the data you have. If it's pretty obviously not bell curve, then you can conclude the data is not really normal, and then your analysis will head in some other direction. Then step 2, identify outliers. If there's more than one outlier present, you could conclude the data is not normal. One outlier could be an error or the result of chance variation. You want to take a look at the picture and make an assessment based on how the data looks. One outlier even could have a dramatic effect on results. You want to really weigh carefully whether outliers are legitimate or are the result of some sort of measurement error. Okay, make that normal QQ plot. If the histogram is basically symmetric and the number of outliers is relatively small, use technology to make the QQ plot. Nobody draws a QQ plot by hand. Apply the following criteria to decide whether or not the distribution is normal. So looking at the QQ plot, if the pattern of the points is reasonably close to a straight line and the points don't show some systematic pattern that is not a straight line pattern, you could conclude that it's not a normal distribution if either of these two conditions applies. The points are not along a straight line or reasonably close, or there is some systematic pattern that is not a straight line pattern. Here's a couple of examples, basically just yes or no. We want to decide, taking a look at these, if these might be QQ plots from a set of data that would be normal or not. So taking a look at A, it looks like the data deviates pretty strongly from a straight line, so it's probably not normal. Okay, and then going on to B, the data here looks pretty close to lying along the straight line, so I'd say that it looks probably normal. Then in part C, it looks pretty good, maybe not as good as the last one, but it's still probably okay. Data lies mostly along a straight line. In D, definitely not normal. Okay. All right. So the purpose of this has been to really be able to take a look at a set of data and determine whether the data is from a normally distributed population or not. And also, along with a histogram, the QQ plot is one of our biggest tools we have to work with. All right, so in this part, I wanted to show you how you can use StatCrunch to generate a QQ plot if you want. So I've signed into my math lab and I started StatCrunch, and just for our purposes, I'm going to use textbook data. So let's use the body data set. So let me click on that. It'll take a minute to bring that up. So let's check and see if pulses are normally distributed. So we're going to go to graph and then go about halfway down to where it says QQ plot. Once you've selected QQ plot, you have to decide what would I like a QQ plot of. I think I said pulse, and then you can play around with some of this other stuff, but I'm just going to hit compute here, and that will give us a QQ plot. So it looks like the pulses are not, don't deviate too far from a normal curve. We could generate also a histogram so that we could compare those two side by side. So let's do that. So here's a histogram for pulse, and then we'll compute. All right, so there's the histogram along with the QQ plot. So this one, it's not really normally distributed, and also there are these two really low pulses. So, or more than two actually, two bars with low pulses. So to me, there's a couple of outliers there. So I don't know if we really want to consider that close to normal or not. The middle part is pretty good, but the ends, it does deviate some from that line of best fit. Okay, let's try one more. Let's try heights. So graph. Let's try QQ plot. And we were going to do height. probably guess that this is going to be pretty normally distributed. And that looks a lot better than our last one. Here the dots lie a lot closer to our line. There's this one dot here in the low portion of the window that looks like an outlier. So let's see how that's going to end up looking on the histogram. So we'll go back to graph and then histogram. And then we were doing heights. And click on compute. And there's our histogram. So yeah, this one looks a lot more like a bell curve. There is that one kind of outlier here at the bottom that is throwing things off. All right, so there's just a couple of examples of how you can use StatCrunch to generate both histograms and QQ plots. If you have any questions, let me know, and have a great day.